Cohen, Marianne Stevek, Allison Bartolucci, Tony Anderson, Liesl Neil Thamat, Shaista Sadruddin, Kelly Ketterson, Dara Berger, and Charlene Aloof. Without any further ado, it's my pleasure to introduce the panelists of today's roundtable. We're going to start with Dean Morbeck, who's going to speak to us about insemination, IVF and ICSI, and about lab setup. Dean is the Scientific Director at Fertility Associates New Zealand, Sunfort International Fertility Center, and an honorary lecturer at the University of Auckland. He oversees science in IVF clinics throughout New Zealand and Malaysia that annually perform greater than 4,000 fresh cycles. Prior to moving to New Zealand, Dean was an associate professor at the Mayo Clinic. Dean, please take the mic.
Great. Thank you, Dawn and Peter, and welcome everyone. It's great to be here again. I will start out by just pointing out I won't be spending much time on the insemination and ICSI. I'd like to refer anyone who did not see our webinar from last week to that, I think, very engaging conversation about how much ICSI we use and how to improve our ICSI rates. So really the focus for this roundtable, although those questions are always open for that, the roundtable that I'll present about is, as it shows on my slide, that it's ART laboratory setup. And I'm just going to go through some of the specifics, really different areas of key points that we want to hit on. We don't have a lot of time. We could spend a whole session just on this. So ART laboratory setup. We'd start with what, of course, is the most important, which is air quality. That's what immerses everything that we do. It's the foundation. And, you know, I don't have to spend a lot of time on this, although, again, we could spend the whole day talking about it because there's so much about this that we still don't have complete agreement on. But this consensus document from 2018, I think, is a great starting point, and everyone should have seen it and read it. And really, we highlight things like, you know, what kind of filtration. Everyone should have HEPA. Obviously, in Europe and in Asia, there's a big focus on this regulatory-wise. But the chemical air filtration to remove VOCs is really critical. That's something that I think is absolutely necessary. The issue of clean rooms and how you define a clean room. You know, we are working in biological clean rooms versus, you know, manufacturing clean rooms where it requires really, really few particles, like for semiconductors. You know, this isn't something that we agree on either. There's some clinics that do go to that length. And then whether you would need an airlock to go into the lab, you know, do we need those levels of control? And then we have other areas of design, like, you know, what came out of this document, which made it clear that we keep andrology separate from embryology. We keep our supplies away from our embryology. They're in a separate room, and we off gas. So a lot of good elements that are in that document. So let's talk about some specifics regarding what different options we have in the laboratory. So if we look at the workstation options, here I show you kind of 3 levels of workstations, and there's probably a 4th one, at least really extreme, but let's just, these are the 3 most common. The first one on the far left is actually our pickup station in Auckland, showing you no hood, where it's on the workbench. We do have HEPA filtration, so we've got, you know, for the room itself, the HVAC is giving us good quality air. And there's you know, varying beliefs around the world about, do you need a hood to be able to actually just do your practice? Now, in the EU, you do, I believe. I know that it requires a certain class of air to be doing any of the work, which would require then this middle screen, which shows working in a hood with a laminar flow. And then the most extreme would be something like here, which is one unit that we also use here in New Zealand. This one happens to be just, you know, like an isolette, same function, where you've got complete control over temperature and gas, and potentially humidity as well while you're working. So you're basically working in an incubator. From there, we move on to the actual micromanipulation workstation. And I show this picture from far away because I want to point out a couple things. Obviously, this can be done in a hood as well. There are systems out there. There's a lot of new equipment in our field. If we were at one of our big conferences right now, you could see all the gadgetry that's out there. I've always used a standalone on the bench system like this, but I like to point out, here's the above there, you see that's where the direct airflow comes in. It's not right over the top of this, so something we like to believe is important is to keep this pretty isolated from traffic and airflow. And so whether or not it's required to be in hood, again, is probably somewhat dependent on where you're located. And then I'll finish covering this section by talking about gas delivery and liquid nitrogen storage. And so this picture here is actually from our Malaysian clinic in Kuala Lumpur, showing our vapor phase storage along with liquid nitrogen dewars here. Just as an example, the first picture I showed about how we would function in Auckland is completely at the other end of the spectrum from what's being done in Malaysia, where we have a clean room setting. We have airlocks coming in. We have all of this really sealed walls, and so, but the delivery of gas to this, you can see that we actually have gas coming from an outside room that is allowing delivery of gases to the facility without bringing it inside the lab. I show you this picture, which is from one of the labs I've visited on some of my different trips. It's not one that I oversee. You see a couple of tanks in the room, which means that we're not having gassing available. This isn't ideal, and this should be avoided, especially here where it doesn't have them attached to the wall. For all of those of you who are following our OSHA standards, this wouldn't be acceptable. And then lastly, whether we're using big tanks or liquid nitrogen storage small dewars, this is a whole nother topic, and one that we've heard about on this webinar, and one that I think we'll continue to hear about, because I think we have to live with both large and small storage systems, and we need good monitoring of those for safety purposes. So I think that's all I've got.